This is a little visualization I've been playing with for helping to understand the so-called Quicksort algorithm. The Quicksort algorithm was developed by a British computer scientist. He's a knight, I guess, now. Here's what he looks like according to Wikipedia. He's still alive. Seems like a nice fella. There's been a lot of analysis on this algorithm. It's a pretty simple algorithm. Usually it's kind of demonstrated in a kind of combined way where it's sorting everything in place. And what I wanted to do was kind of break it up into the steps to show it as they happen separately. Um, so what you can do here, we have a list of values to sort, and the way it works, it picks what it calls is a pivot element, partitions the set into elements that are above or below that pivot element, and then does the same thing on the subintervals, and just keeps doing that until it's sorted. And usually it has ON login behavior, um, but there are some weird cases that can cause it to have ON squared behavior, and I give a way to see how you can see that in by clicking that little button. But first, let's just kind of go through, watch how it does it here. So the first thing it does is pick a pivot. Boom. So in this case, I'm always picking the leftmost element of a subset as the pivot. So it picked the pivot, and now what it does, it partitions the set into those values less than and those values bigger than this pivot. So if you click accept, here it's moved everybody, or it's found out the relationship of all the other values relative to the pivot. So here's all the guys above it, here's all the guys below it. And what this means is that the pivot is in its sorted position. He's done. And what the way the method works, it divide and conquer. It does the same thing over this interval, the same thing over this interval. So if you go to the next step, it picked the leftmost, it picked the leftmost. Here I turn him gray because he's already sorted. We're done with him. So now it's going to do the same thing here that it had done before. It partitions everybody in this set relative to this pivot and does the same thing in this set. Everybody on the left side here is less than him. Everybody on the right side is bigger than him. Same thing here. And now also these are in their sorted position. And you can hear my dog outside. So now these are sorted. It does the same thing over this interval. Same thing over this tiny interval, which is kind of degenerate, but it won't take long. And the same thing over these two intervals. And what I've got a little thing here, you can now you kind of see the pattern, you can play with it or whatever. You can also say, okay, just keep going and show me as you go. What it's going to do is keep going through. It gets a little slower here. It's not a problem of the algorithm. I'm doing a bunch of animations that probably need some optimization, and so it will slow down towards the end, which kind of has a nice effect for a little bit. But do a few more times. It rolls down. This is going to kind of dealing with that optimization thing will be a nice application of Chrome. Okay, boom, it's sorted. I don't know how many steps it took exactly there. Again, it's ON log in general, as long as the values are not too crazy. What does crazy mean? Well, I have a way to see that. The worst case, actually, is when it's already sorted, if you're going to use this strategy of picking the leftmost pivot. So, here is what the worst case looks like from a performance point of view, where you've got to do a bunch of comparisons. And you can see that by clicking do auto. It's hard to see that you've actually picked anything down here because the bars are so small. But let it go a minute. And what it's having to do is it's not being able to break it up very much. It's having to do one little guy at a time. So and there's basically n comparisons being done at every step, and this is going to have to do it n times, and so that's why it's ON squared as a worst case. This is the worst case, again, when you're picking the leftmost pivot. And there's some other strategies for picking the pivot based on, there's really the best cases around the median of the values of the values in a subset. But what's kind of cool is if you've randomly shuffled the values, the you're kind of guaranteed statistically to be that leftmost pivot is going to be between the 25th and 75th percentile, and apparently that's enough to get the ON log n behavior too, which again kind of points to the power of random numbers in a kind of a nice way. So there, he's going to take a while. I'm going to stop him. Now another case, what you can do, I don't know if I showed this, you can look at a small case, which converges a little quicker, but it might help to see some of the things going on. And again, what I wanted to show is, when I was playing with this visualization, is how the pieces move together here. So how the pivot, how everything goes relative to the pivot on subsequent steps, trying to keep context from where you were to where you go to. Boom. Keep it a little more until he's done. And he sort of, there you go. This is online. There's a link in the description. And that's about it. And see you later.